So just a quick announcement. There's 2 lectures from last week that are missing. One is there now. So the one from the 25th is now, I had to re-record it. It's now up. The one from the 27th also didn't record. So I went into the directory with where the recording is supposed to be, and there's no files in there. So I also have to re-record that one. So I'm going to try to do that one later tonight and post the video from last Friday later this evening. Assuming this one records, I'll post this one after class, but who knows? It doesn't seem to be working well in here. At the end of the last lecture, we were talking about command line arguments, so writing our own scripts and using command line arguments. I guess there's 2 things you need to know about using, well, for now, there's 2 things you need to know about using the command line arguments. If you want the number of command line arguments, that's stored in the parameter hashtag or number sign or pound sign, whatever you want to call it. Right? If you want to get the value of that thing, then you need to write dollar, then the symbol. Right? And so in this script here, called Viewargs, right, it prints out the number of arguments. So the number of arguments to the script is just dollar. To get that value, it's dollar number sign. Right? Now the rest of the parameters are stored in order in the variables 1, 2, 3, 4, 5 for as many command line arguments as you have. Right? So your first command line argument stored in the variable or parameter called 1. To get its value, you need $1. Right? Second command line argument is stored in the parameter called 2. To get its value, you need $2. Sitting inside of $0 or inside of 0, the variable 0, is the path name on how this is the path name storing how the script was started. So if you're in that directory where the script is, then it's just going to be the name of the script. If you call the script from a different directory, it's going to be the path name up to the it's going to be the path name that you use to call the script. Sorry. Right. So $0 or 0 lets you get the path name, lets you get the file name of the script. If you run this little program here, so it's called Viewargs, you don't have to pass in. You can pass in as many command line arguments as you like. So if I pass in 0, it says there are no command line arguments. Right? How did I run the script? Well, I typed in ./viewargs.sh. Right? If I pass in 1 command line argument, so ABC, right, it says there's 1 command line argument, right? And that command line argument was ABC, right? And so on and so on and so on. Notice that the script works, right? It actually does try to print out the value of the command line arguments 2 through 10, right? We didn't give command line arguments 2 through 10, but the script still works. There's no errors or anything else, right? So the rule in Bash is if you use a variable or a parameter that has no value, Bash automatically creates the variable, or Bash automatically creates the variable, sets its value to the empty string. If you read the Bash documentation, you'll often see the word null used. When they say null, they mean the empty string, which is very confusing because null means something else in C. So a variable that doesn't exist or doesn't have a value, a variable doesn't exist, it automatically gets the value, the empty string. Which is why this script works, even though we didn't pass in 10 command line arguments. If you're trying to process lots and lots of command line arguments, so you have more than 9, then to get the 10th or higher command line argument, you must put the number inside of braces. Right? You're allowed to put any of the other ones inside of braces as well. But for more than 1 digit for the command line arguments, you have to use braces around the number. So once you're able to once you have access to command line arguments, you can now make scripts that are a lot more useful or a lot more intelligent. Right? So instead of printing hello world, we can print the name of the user if the user passes in a command line argument. So let me just pop open here. Here, right. So here's hello u.sh. Right. So this one's hello world, except it takes in a command line argument. Right. Takes in 1. And now it just echoes it just says hello, comma, space, and then the name of the command line argument, or the command line argument, I guess. So for example, hello you, and then CISC220. Right, now it says hello CISC220, right? So there's an example of using a command line argument. Now on your assignment, there are some questions that say stuff like, if there's no command line argument, your script should exit and do nothing. Right? So here, for example, if the user doesn't provide a command line argument, then it might make sense not to try to greet the user or to greet them in a different way. So to do that, you need a if statement, which we haven't talked about yet. So you can jump ahead to the conditional statements notebook if you want to and read what's in there. Or I can just show you an if statement right now, which is probably the easiest way to do it. So if you want to check the number of command line arguments, then the easiest way to do that is to use the following notation. So double round bracket. Right? So if space, double round bracket. When you use the double round brackets, you're going to use an arithmetic comparison here. Right? So in other words, you can only compare numbers inside of this double round bracket construct. Right? So here I want to check, is the number of command line arguments equal to or greater than 0? Right? So if $number greater than 0, greater than 0, like that. Right? So in other words, if there's at least one command line argument, go ahead and use that command line argument. Right? So if it's greater than 0, now the syntax of the if statement is funny. Well, it's not funny. It's just different in Bash. It's different than the other than the languages that you've learned. Right? So if double round bracket, then your condition inside, that's an arithmetic condition. Semicolon after the round bracket, then, and your if statement ends in phi, so fi. So I want to print that greeting here, like that. Right? So if the number of command line arguments is greater than 0, right, go ahead and print hello, comma, first command line argument. We don't care about the remaining command line arguments. Right? And that would satisfy, so that's one way to deal with the number of command line arguments. Right? On Wednesday, I'll show you different ways of dealing with it. So you can construct more complicated expressions involving the command line arguments. I think that will get you through questions 1 through 4, I think. It's only the 5th question where you have to do some extra, where your if statements start to change a little bit. So if we run this now, and this time pass in no command line arguments, it doesn't do anything. Right? Now if you pass in 1 or more, so blah, 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 right, it'll just use the first command line argument and greet that user. I guess I'll show you an if statement while I'm here. An else statement while I'm here. Right? So if you want an if else, then it's just an else. Else, and then phi closes the if statement. Right? So here, I guess if they've passed in no command line arguments, it's up to us what we want to do. You can either output an error message and say, hey, you need one argument so I can greet you. So let's do that. So echo missing command line argument. Okay, so we'll try that. All right, so now you get, right? So if you run the command with no command line arguments, you now get missing command line argument. Right? Now that error message really should go to standard error. It shouldn't go to standard out. So in general, your error messages in Bash should be printed to standard error. We don't know how to do that. Right? I can redirect this state. I can redirect the output of echo to a file. We know how to do that. Right? But we don't know how to redirect it to standard error. So the way you redirect it to standard error is, so you use the redirection symbol, right? So greater than, and then you use and to, like that. Right? And so what that does is it takes, technically what it does is this. Right? So 1, that's standard error, that's standard output. Right? So this says copy standard output onto standard error. So remember, number 2 is standard error. So the syntax 1 greater than and 2 means copy standard output 1, or copy file descriptor 1 onto file descriptor 2, which copies standard output to standard error instead. Right? So if I run that, you're going to get the same thing because standard error by default goes to standard output. Right? But if I redirect standard output to a file, right? Now you can see that, oh, it really is standard error that's being printed, right? Because I've redirected standard output to a file. So if something shows up on the screen, it's because standard error is because something's being printed to standard error, right? So now that message goes to standard error, which is where it should go. And the last thing you should do, so if a command in bash encounters an error, it should set the exit status to some non-zero value. So to some positive value that's less than 128, right? And you can pick whatever value you want. So I'm going to set the exit status to 1 in this case. Oh, here. So if we want to look at the exit status, we can just echo dollar question mark, sorry. Right? So the last command that was run has an exit status of 0, right? So we don't want to do that because technically that the last command we ran encountered an error. We should set standard error. We should set the exit status to something else. So to set the exit status to something else, you can either return. In bash you would exit. So the command is exit, and then you'd pass in the exit code that you want to exit with. So I'm going to do exit 1. Run the program again, right? Look at the exit status. Now the exit status is 1, right? The exit status is useful. So setting it to a non-zero value or a positive value is useful because now other programs can make use of the exit status of this command, which they might want to do, right? And we'll see examples of that later in the course. Okay, is there another? Yeah, let's look at another script, I guess, quickly. And so one more script. So here's our named. So we had a script called make shell, MKSH, that just made an empty shell script file, called it temp.sh, and and gave it the user execute permission. Right. Oh, we also put in our hashbang bin bash, right, so that it made it a bash script. Right? So always making the file temp.sh is a little inconvenient, right? Because now I have to rename temp.sh to something else. But now that we know how to use command line arguments, we can go ahead and just use a command line argument. Right? So here we can run named shell and give it a name. So named shell, my script. And now there's a program a script called my script. Right? ls minus al my script. Right? It has execute permission. Right? So we can actually run that script, cat my script. Right? And it even has the correct starting line. Right? So from here you can now fill in the details of your script file, and you've got a runnable shell command. Okay, moving right along. So for that if statement, there's another place you can find the syntax for that if statement. It's in the Arithmetic Notebook right here. Right, so we're currently right here. It's down here a few notebooks. So in the Arithmetic Notebook, there's a section called using the double round bracket as a condition. Right, and there you can see I'm checking the number of command line arguments. Sending the error message, the standard error, and exiting with a non-zero exit status. Right. So if you need to reference how to do that, just go look in the arithmetic expression notebook. Okay, so that takes care of the introduction to bash scripting. And so in the next part now, so in order to make a usable script, well, to make a script that does something interesting anyway, you probably need variables. Right? And so that's the next notebook. And variables in bash are unusual compared to the languages you're used to. Okay. So a variable in bash is a parameter, so something that stores data, that starts with a letter. Right? In bash, a variable is just a name that refers to a memory location, right? Holding a piece of data. Right? Okay, so a variable has a name. So bash says that a name is any sequence consisting solely of letters, numbers, and underscores. So it's the same as Java. Right? And it has to begin with a letter or an underscore. Right? So again, same as Java. Generally, when I write out a variable name in bash, it's going to be in all lowercase. If it's multi-word, it's usually, I split the words with an underscore, but not always. Generally, bash programmers don't use camel case. And what else is there? Try to keep your variable names relatively short, but meaningful, right? So you want them to be readable. Anything else? Yeah, that's about it. Okay, so I need to be in this directory here, scripts variables. So let me just change into that directory. Sorry. What's here? Oh, there's not that much here. Okay, so. Okay, so the thing you need to remember in bash is that as far as bash is concerned, everything, so all data is just a string, right? Or a sequence of bytes. Right? That means even numbers, as far as bash is concerned, is just a string. Right? So bash variables are untyped. Right? Depending on the context and where you're using the variable, bash might interpret the value of the variable to be a number, an integer value. Right? But otherwise, it's a string. Right? There's no floating point arithmetic in bash. If you type in some floating point expression and it works in your shell, you're probably in Mac and you're probably on the Z shell. Right? In bash, floating point expressions don't work. Right? You can't do floating point arithmetic. All right, so now variables in bash are untyped. So this sort of looks like Python, right? It doesn't look like Java. There's no special syntax for declaring a variable name, right? So the first time you use a variable, bash will create that variable, right? Even if you're using the variable on the right-hand side of an assignment, right? So I mean, if the first line of your script is var equals, I don't know, $X, right? Remember the dollar sign lets you get the value of X, right? That's the first line. So there is no variable X when this line runs. Bash creates X, sets it to the empty string, and this line runs without any errors, right? So now you've got two variables. You've got var and you've got X, both of them in the empty string. So that's what ends up happening, right? You don't get an error message or anything, or a warning or anything to tell you that you've used a name that doesn't exist yet. Right? This is very problematic for people new to writing scripts because you can easily make a spelling mistake in a variable name and not realize it. And now your script works, you don't get any warnings because bash takes your incorrectly spelled variable and just makes a new one. And the script runs as though it was the empty string. So be very careful when you're using variables. If you misspell one inadvertently, you'll end up with a script that still does something, but it probably doesn't do the right thing. Assignment in bash is the same as many other languages. It uses the equal sign to do assignment. Now, in bash, you're not allowed to have spaces around the equal sign, right? Which is, again, strange compared to the other programming languages you're used to, right? Depending on how you were taught to write your programs, right? So it may have been drilled into you that there should always be a space around your assignment operator, right? If you're in Eclipse and you auto-format your code, it always puts a space around your equals operator. In bash, you can't have the space there, right? So if you want to make a variable and set its value to 2, you must write a equals 2 with no spaces anywhere, right? As soon as you insert a space, you'll get an error, right? Which I can show you in a shell. So you can type these commands directly into your terminal. They will work, right? So a equal 2, everybody's happy. A space equals 2, that command is not happy. The shell's not happy, right? Why is it not happy? Because it sees an A, then a space, right? So it thinks A is a command. There's no command called A, right? So it thinks that you're trying to run a command A, you're passing in command line arguments equal and 2, right? That's how the shell is interpreting that statement. Similarly, if you write a equals space 2, right? Now you get the funny command, output command 2 command not found, right? So what's this doing? So here it sees the a equals, so now it's assigning something to a, right? Turns out in this case it assigns the empty string to a. And then it sees the number 2, so now it tries to interpret the 2 as though it were a command, and there is no command called 2, right? So your error messages that you get in bash aren't particularly helpful either. Right? So you have to be very careful here. If you're doing the assignment, a equals something, right? No spaces anywhere. Here's another example. So I'm going to make a variable b, and I'm going to set it equal to some string. Right now, here I've got the some string double quoted, and that's to prevent word breaking, right? Or word splitting. What happens if you don't do it? A equals some string, command string not found, right? So what's happening? It does the assignment a equals some, then it sees a space. So it tries to interpret string as though it were a command, and that's not going to work, right? Even more confusing, I guess. Let's try this. A equals some and then ls, and now you get ls running, right? Which is really bizarre, right? If this is in your script, this is what will happen, right? A will get assign the value some, and then the ls command will run. So that's probably not what you want, right? So if you have a string that you want to have a space in it, make sure that you either escape the space or you double quote the string. Okay, so when bash does a substitution, when you write something like $sign variable name, or equivalently, var equals $sign x. So you're always allowed to put the variable inside of braces. So this is always legal. Sometimes you have to do this, and I'll show you an example of when you must do this, right? In either one of those cases, these are both substitutions. So these are both examples of parameter substitution, right? Now remember what parameter substitution does, right? So that's a parameter substitution. So what happens is you get the value of x, and you substitute it or replace all of that with the value of x. And that becomes a string, right? So you can do string concatenation like this, right? So $A, $B, right? So it takes whatever $A is, in this case it's 2, right, the string 2, and then it takes $B, which is some string, and just mashes them together into some string, right? To some string. So A equals 2, B equals some string, right? And then C equals $A, $B. You can put that in braces too if you want to, right? Echo $C, right? And there's C is to some string. Okay, so that dollar symbol, that's how bash dereferences or that's how bash indicates that you're after the variable, the value of the variable, and not a string, right? So remember in bash, everything's just a string, right? So if you wrote var equals x, right, then bash has no way to know, or bash just assumes you mean the string x, right? And you don't mean the variable x, right? So that will just assign the string x to var, right? It won't use the value of the variable x, right? If you want the value of the variable x, you have to write dollar in front of it, right? If you want to be, so if you're paranoid, whenever you're using a variable, you'll always put the variable name inside of braces, right? It usually doesn't matter, but every once in a while, something will trip you up, and it does matter. There's actually a place on the assignment where it matters. So you have to be a little bit careful. Right? Okay. Right. So whenever you write dollar variable name or dollar brace variable name, you're doing a variable or parameter substitution. Right? Sorry, parameter expansion or variable expansion, I guess is the correct term. Right. And so if you remember back to the expansions notebook, remember that parameter expansions happens in step 3, right? So it happens before word splitting happens. So there's just an example of using a variable. So I'm going to make a variable called message, assign a string to it, right? And then I'm going to use echo to print the message, right? And so $message, that's the value of the string, right? And so that just prints the string welcome user, like that, right? In bash, there's a variable, there's an environment variable called all caps user, right? So capital U, capital S, capital E, capital R, right? That's a built-in variable that is equal to the current user's username, right? So the current user on my computer is my name, so it echoes my name, right? Again, what happens here, right? We take the variable that's stored in user and replace $user with the value of the variable, right? So we do that's the variable substitution right there. And okay, so nothing terribly useful here. Let me just go back and run that cell that's up there, sorry. So that I have A, B, and C. All right, so right there, there's an example of actually using the values of A, B, and C. Right, so if I run this, I'm going to get 2 some string and 2 some string. Right? Again, remember that if you want the value of the variable, you have to use that $sign in front of it. Right? If you don't, you just get A, B, and C. Right? Again, because bash has no way of determining that you mean the variable A. Right? It assumes you mean the string A. Okay, so bash creates a variable when you first use it, and it doesn't matter where you use it, which is crazy, but that's the way it works. Right? So unlike other programming languages, it's not an error to use a variable before it's been declared. Right? So the following is legal. Right? There is a way to configure your shell so it's not legal, but by default, your shell is configured so that this works. Right? So I have no variable called y in my shell right now, right? So that works, right? It doesn't print anything when you try to print it, right? So if you echo x, nothing comes out, right? That's because it's printing the empty string, right? So what happens here is gets the value of y doesn't exist, so it makes y, sets y to the empty string, and now x becomes equal to the empty string. So when we echo the value of x, we get the empty string. All right, now the fact that bash will automatically create a variable when you use it is why this thing here exists, right? So you might wonder, why can't I just write $sign variable name all the time, right? And the answer is because sometimes bash gets confused, right? The problem with the bash's variable naming scheme is that it allows the underscore character to be part of a variable name. So if you write $x underscore something, right, it thinks the underscore is part of the variable name. And if you don't have a variable name called x underscore something, bash makes one for you and sets it to the empty string. Right? Now, unfortunately, there's a lot of cases where you want to make a variable, you want to output a string that has an underscore in it. So for example, right, here's our script called bad backup. Right? So it's going to take in one command line argument, right? So that's the name of a file. So $1, that's the name of a file to back up. Right? So I'm going to store the name of the file in the variable called in. Right? I'm going to copy that file to a file called whatever the name of the file is, _.back. Right? So out is going to be the value of in, right? Followed by an underscore, followed by .back. Right? So for example, if I have a file called, so if I run /bad backup, f, right? Then in your script, in is equal to f, right? And then out is supposed to be f underscore dot back. Right? So I guess we'll run it here now. So I'm going to make a file called my file. It's got a space in it, which is inconvenient, but that's life. Right? I'm going to try to back it up. Right? Now remember, when I pass in the name of my file, because it has a space in it, I have to double quote it. So when I pass it in as a command line argument, it's double quoted here. Right? Now, if this script works the way I intended it to, I should get a my space file underscore dot back, but you don't. Right? Instead, what you get, I got a dot back. Right? Where's my file? My file is still here. Right? Is there an underscore or something anywhere? There isn't, right? No, there isn't. Right? So what ended up happening here? Right? So what ended up happening here was, when bash reads this line here, right, it sees $, then in, then underscore, right? So the underscore is a legal part of a variable name. So bash thinks you're trying to use the variable in underscore, right? Which is the empty, which doesn't exist in this script, right? So what does it do? It makes a variable called in underscore and sets it to the empty string. Now it substitutes the empty string for all of that, right? And now you end up with dot back, right? Empty string dot back, right? And so your output file name becomes dot back, right? And not my file underscore dot back, right? And so that's one of the situations where you have to surround the variable name with braces. Like that, right? So the braces actually delimit the entire variable name. Right? So when bash sees this, it says, oh, you mean the variable in, which does exist in the script, right? The underscore is part of the string now. Right? And so if you look at the file called backup.shell, it actually makes that correction, and now it works the way you want it to. Right? And now there's my file.back right there. Right? So if you're super paranoid, you always put your variable names inside braces. Right? Otherwise, remember, if you're putting in an underscore after a variable name, there's a pretty good chance that you have to put braces around the variable name. Okay. Expansion results so what are you going to use variables for? So variables can store strings, right? But they can store the result of any expansion, which is handy. That means you can run a command and store the result in a variable. Right? Or you can create an expansion, like a brace expansion, right? And store that. There's a missing, oh no, there isn't, right? And store that in a variable. Is that true? Hang on just a second here. Hold on, something's bothering me about this. Is this true? Does this actually work? Hang on, let's see if this works. Okay. So remember what this expansion does here, right? It takes the prefix, right? This expands to the string good, the string bad, and the string ugly, right? With a space in between each. And it sticks the prefix onto the front of each one of those strings. Right? So here you get the good, the bad, the ugly. Right. Another example of brace expansion. Right? So this one uses a range. So remember what this one does? It gives you the strings 2020 through 2029 in increments of 3. So you get 2020, 2023, 2026, and 2029. Right? Tilde is your is your tilde expansion. So it expands to the current user's home directory, which you can see there, right? And remember, that's a file name expansion right there, right? So that matches any file name in the directory that ends in IPYNB, right? And you can see there's lots of those files right there, right? So you can store some of those strings inside a variable if you need to. Or can you? Right? So let's take a look at these. So what's happening here, right? So we're getting the, and then we get this, which is funny, right? We don't get the expansion. We don't get the result that we had back here, right? We have some years, and again, we don't get the expansion here either. Right? I remember this now. This line here is wrong. This doesn't actually work. Right? The one line that does work is that one right there. Right, is that true? Home directory. 2 of them work. These 2 work right here. Right? So that one works. Right? So I can store, if that expands to my home variable name, that one works. So homedir does in fact store that directory name. Right? And that one works. Right? So your file name expansion, you can also store the results in a variable name. The other 2 don't work. Right? So the brace expansion doesn't work. Right? You cannot store the result of a brace expansion in a variable. All right, so what about command substitutions? So that's another type of expansion, right? Command substitution. So can you store the result of a command in a variable? And the answer is yes, you can. Right? And this one is often extremely useful. Right? So for example, I can run the CalSay program. Right? I can have the CalSay CISC220, but then I can store all that in a string, in a variable. Right? And so in a parameter expansion, in a command expansion, dollar, round bracket, 1 round bracket, not 2. Right? So round bracket, then the command and its arguments, and then the closing round bracket. Right? So what bash does here is it launches a new shell, runs that command in the new shell. Whatever that command outputs to standard output, it captures that and replaces all of that, and replaces all of this with the output of the command, right? And stores that in the variable. So if we run this command here, right? Well, let me comment out the second line first. Okay, so if we run that, right? The CalSay program runs, prints CISC220 with a cal, right? But all of that gets stored in the variable mu, right? So nothing appears on standard output, right? But then, whoa, sorry. But afterwards, so after running that command and storing the result in the variable, I can then print the value of the variable mu. Yes, question?
What happens if you ran that without the double quotation?
Without the double quotation. Here it doesn't matter. Because that string has no spaces or funny text in it, right? So that one doesn't matter.
Because when I run it, like without the double,
Without the quotes?
it does them all in one line. Like it prints the CalSay.
Like that?
Sorry, around the mu.
Oh, around the mu. Oh, yeah. Okay, so that's a good question. That's a better question.
Yeah.
All right. Okay, so if you take off the quotes around mu, right? So remember what the order of the expansions are, right? So go back to the expansions notebook, right? Brace expansion happens first, tilde expansion happens second, parameter expansion happens third, right? Command substitution, then arithmetic substitution, and then word splitting happens here, right? So, parameter expansion first, word splitting second. Where are we here? Okay. So when the bash sees echo $mu, right, it does the parameter expansion for mu, right? So it takes whatever string, it takes this string here. Sorry, all of this as one string, right, and substitutes it for $mu. Right? So you get all of that substituted for $mu. And now echo runs, but when echo runs, before echo runs, bash is going to do word splitting on the string that was substituted. Right? So remember what word splitting does, it takes all spaces, new lines, and tabs, and replaces them with a single space. Right? So there's a new line character at the end of the first line, there's a new line character at the end of the second line, there's one here, and so on, and so on, and so on. Those all get replaced with a space, and so your output just becomes that. So that's what's happening there. Yeah. So if you need the value of your variable unaffected by word splitting, it has to be quoted. Right? This is particularly important when you're working with file names. Right? So if you're trying to, is there an example? Let me just quickly check if there's an example somewhere in this notebook. There isn't. I'm going to go back, in a minute, I'll go back and edit one of the other scripts that we were talking about. So let me do this one first, and then I'm going to go back and show you what happens if you don't quote properly. Oh, okay, so that's an example of an arithmetic expression, arithmetic expansion, right? So dollar, double round bracket, some arithmetic expression, double closing round bracket. So that thing expands to whatever the value of the arithmetic expression is. Right? So for example, right, here I've got a variable called x. Its value is 2. Right? Now I've got my arithmetic expansion here. Right? So x plus 1. Now the interesting thing about the arithmetic expansion, right? So bash knows that this is arithmetic, right? Because it's inside of double round brackets, right? So because bash knows that this is arithmetic, it knows that x is not, you're not trying to create a new variable here, right? So in other words, it knows x is an existing variable. That's not true, sorry. It treats x as though it were a variable name, not a string, right? Because it knows it's trying to do arithmetic. So here, you actually don't need the dollar sign in front of the x, right? Because bash knows you want the value of x here. Right? You don't want to make a string x, because it doesn't make sense to add the string x to 1. Right? So here, bash does x plus 1. So in this case, it's 2 plus 1. Right? The value is 3. The 3 gets substituted for the entire expansion. Right? So now you get 3 here for y, and now you can print the value of y. Right? OK, so let me go back and do the what happens if you don't quote a name properly. Named shell. So this is a good one. Oh, this one is busted. OK, so this script is broken. This has an error in it. Right? And so let's see what the error is. What is this? Introduction. So cat named. OK, so if you run this script, name shell. OK, so I want to make on my own. Oh, so this is, yes, I want to make a script called my script. So it's got a space in it. Right? So I call the script passing in the string quoted. Right? So in other words, the input really is quoted, so it's not going to word break. When I run the script, I get this funny error message. Right? It says named shell line 5, $1, ambiguous redirect. You say, well, what is that? Right? What's going on there? Right? And then if you read more, it says change mode, cannot access my. Right? No such file or directory. Change mod, cannot access script.shell. No such file or directory. Right? So you're getting 2 error messages from change mod, which means you're probably trying to change the permissions of 2 files, which is exactly what's happening here. Right? So what's going on here is you passed in my script.sh. Right? It's got a space in it, so you passed it in, quoted, which was correct. Right? But when you write $1, what happens? Right? The value of $1, of whatever's stored in 1, gets substituted. Right? And the value that's sitting in 1 is my script.sh. Right? So that's what happens. So when it substitutes, even though the original input was quoted, when it does the substitution, it's no longer quoted. Right? Similarly down here, this becomes my script.sh. Right? So when I try to redirect that to that, right, bash barfs. Right? It says $1 is an ambiguous redirect. Right? When you try to change the permissions of those 2 files, bash barfs again. Right? Now in this case, we're lucky, it barfs. Right? So this says change mod, right, of that and that. Sorry, there's a dot missing there. Right? So change the permission of those 2 files. Right? I really want there to be 1 file here. Right? So whenever you're using a variable that's storing a file name, right, you almost certainly have to quote it in order for it to work correctly. Right? So now if I quote the value of $1, right, so now when I substitute my space script.sh in there, right? The contents of that string are quoted. So now word splitting doesn't happen. Right? And so now it correctly redirects the output. Oops, sorry. Alt-tab here. Save that. Right? And so now when I run it, it runs cleanly. And there's a script called there's a script called myscript_sh. Right? And so remember, it's not just spaces that causes this problem, right? Any special character that the shell might interpret as being something else, right? If one of those characters is part of your string, you have to quote that string. Right? So be extremely careful when you're using the value of a variable for some purpose. The one time you never have to quote a variable is when you're doing pure assignment. So if you write var equals dollar something, like that, right? You never have to quote the dollar something. This always works the way it should. If you're trying to use that dollar something, though, for something else, right? If you're trying to use a variable for something as part of a command, or if you're trying to build a larger string, or if you're trying to do any sort of computation with it, and you think that it might have some special character in it, you almost certainly have to quote it, right? So that's one of the things you have to watch out for in a bash script. Sorry, do you have a question or no? No? Okay. Okay, no problem. What time is it? I guess that's a good place to stop. Any questions on today's lecture? I think you know enough to do the first 4 questions of assignment 2, I think. Next class, I'll show you how to write a condition, and then you'll be set for assignment 5, the last question on the assignment. Hopefully this recorded properly.